Hello and thank you for joining me again. Today we're going to shift our mole conversation and discussion into percent composition. So a little bit different way to think about particles, but we're going to talk about what's called percent composition. And so in doing this, my goal for you at the end of the day is you're going to be able to calculate the percent composition of the elements found in a chemical formula. And so that's about as straightforward as I can make it. So here we go. Percent composition. Percent is defined as parts per 100 parts. So think of the percent on a test. You take whatever you get divided what you should have got multiplied by 100. So test grades, you take what you got, divided by what you should have got, which is all of them, or could have gotten. Maybe should is a better way to put it. And we multiply it by 100, and this is our 100 parts. Equals percent. That's how we get our percent on a test, right? And so it's the ratio of a given quantity to the entire sample and then multiplied by 100. We can express how much of each element contributes to the whole in terms of the percent composition. That's what we're going to use this for. So percent composition is a list of the percent by mass of each element in the compound. So you're going to take your mass of your element divided by your formula mass of the entire thing multiplied by 100. That's going to be your percent composition of that element. For example, if we're talking water, water has 2 hydrogens and 1 oxygen. So we know that each hydrogen has a molar mass of 1.01. So 2 times 1.01 is actually 2.02 if you go to 2 decimal points like I do. And I'm going to encourage you to, at least in my course. And so when you multiply that out, you get 18.02 grams of H2O as your total. And then you're going to take each of those individual parts. You're going to take 2.02 divided by 18.02, and you're going to take 16 divided by 18.02, and you should get numbers that come out to my numbers come out to 11.2 instead of 11.1. So I get 11.2%. Which means on this side, I'm going to get 88.8% as opposed to 80.9. When you add these two together, you should get 100% because it represents the total of all the stuff in your compound, all of the particles in your compound. So you should come out to 100% in the end. Okay? If we're looking at percent composition for sucrose, sucrose is C12H22O11. And so again, I'm going to do 12.01. I'm going to do 1.01 and 16. So I'm going to get 22.22 grams here, and I'm going to get 144.12 grams here. So if I do this, mine are going to be a little bit different, but 176 is going to be the same because I still use 16 for oxygen. So if I add these up, I'm going to get 34 at the end of it, but should still have the 242 or 342. I'm going to have the 0.34. So when we do our calculations, I'm going to take 144.12 divided by, in my case, 342.34, and I get 42.1%, which still is the same at the end. 22.22 divided by that is 6.49%. So mine's going to be 6.49 instead of 6.4. And then oxygen will be the same. Should be close to the same because we did the same thing. So, and again, oops. 176.0 divided by that, I get 51.41 instead of 51.5. So mine's a little bit lower, but notice it all comes out to about the same. And this is going to, if you add all these up, I'm still going to get my 100% here. And that's the important piece. You add those up, you should get 100%. Okay, so that's percent composition. You take the mass of your substance, is 144 grams of carbon. That's a C. That's a really ugly C. You have 22 grams of hydrogen, and you have 176 grams of oxygen. And so they should all add up to that 100% total. So what does percent composition tell us about a substance, and how do you calculate this quantity? Those are your review questions. Thank you for your time today. I look forward to talking about empirical formulas with you in the next video. For now, enjoy the rest of your time, and I'll see you again later.